So hi and hello. Welcome to our channel named Algo Exploration. My name is Sami and in this today's lecture we will going to solve the time complexity problems. So my first suggestion will be when you see the problem, pause the video, analyze the time complexity, or we can say calculate the time complexity by your own, and then play the video to check the answer is correct or not. So let's get started. Now our first problem will be this. These three statements are going to execute. Now let's find the order of magnitude of these three statements. Here your order of magnitude is 1. Here it will be going to n, and let's analyze the order of magnitude of this statement. This statement is under the nested for loop, in which the outer for loop is going to run n times and the inner for loop is going to run n by 2 times. So due to the nested for loop, if you multiply these two terms, it will be going to n square by 2. Therefore we can say that this statement is going to run n square by 2 times. So if we combine the order of magnitude of these three statements, then it will be 1 plus n square by 2. Now in the previous video I have told you that we have to consider the dominant term, and here the dominant term is n square by 2. So n square by 2, and according to the a priori analysis, if we neglect the constant, it will be order of n square. So the time complexity of this problem will be order of n square. Now let's see the next problem. The number of statements that will going to execute will be this one, and this one. So here also there are three statements that will going to execute. So the order of magnitude of this statement will be 1 n. Now let's analyze the order of magnitude of this statement. So here also there is the nested for loop, in which the outer for loop is going to run n by 2 times, and the inner for loop is also going to run n by 2 times. So due to the nested for loop, if we multiply this, then it will be n square by 4. So this statement is going to execute n square by 4 times. Now if we combine this order of magnitude of this three statement, then it will be 1 plus n square by 4. Therefore it will be order of n square. So time complexity of this problem will be order of n square. Let's solve the next question. Here it is similar to the for loop, in which that for loop is going to run from 1 to n, but here in this case it is a while loop. So order of magnitude of this statement is n. Therefore the time complexity of this problem is n, order of n. Now let's dry run this by taking n as 16. Now initially I is equals to 1. Now we will check is I is less than equals to 16. Yes, it is. So we will increment the I by 2 times. Therefore I will be 3. Now is 3 less than equals to 16? Yes, it is. Therefore we will increment the I by 2. Therefore 5. And then we will go inside the while loop and check is 5 is less than equals to 16. Yes, it is. And similarly we will go in this way. 7 is less than 16. Then 9 is less than 16, then 11 which is less than 16, 13 which is less than 16, 15 which is less than 16, then 17 which is not less than 16. Therefore, if we count this term, the number of times this statement is executing when n is 16, 1, 2, 3, 4, 5, 6, 7, 8. 8 times this statement is executing when n is 16. Therefore, we can say that this statement is executing for n by 2 times. Therefore, order of n will be the time complexity because we are neglecting the constant term. Now, let's go to the next question. Similarly, when the statement was I equals to I plus 1, the complexity was, it was running n times. When I equals to I plus 2, it was running for n by 2 times. And when I equals to I plus 20, it will be running for n by 20 times. Therefore, we can say that this statement runs n by 20 times. Therefore, the complexity will be order of n only because we are neglecting constant, that is 20. Now let's solve the next question. It is similar to the previous question, that is the order of magnitude of this statement is 1. The order of magnitude of this statement will be n by 10 times because here the for loop is running from 1 to n by the increment of 10. Therefore, 1 plus n by 10 will give order of n. Now let's solve the next question. Here initially the I value is n and we want to check whether I is greater than 1 or not. Let's say the n is 5, so I will be 5. Is 5 is greater than 1? Yes, it is. So we will decrement the I value by 1. That will be 4. So is 4 is greater than 1? Yes, it is. So decrement 4 by 3. 3 is greater than 1. Then 2. 2 is greater than 1. And then 1. 1 is greater than 1, which will be false. So actually it is running for 4 times. So we can say that this statement is running for approximately to 5 times when n is 5. So the time complexity of this program will be order of n. Here, since the I value is decrementing by 10, therefore the order of magnitude of this statement will be n by 10. So we can say that order of n will be the time complexity. Now let's take an example for this problem. N equals to 32. Now initially I value is 1. Is 1 less than equals to 32? Yes, it is. So we will multiply by the I by 2. So I will be 2. Now 2 is less than 32. Yes, it is. So we will multiply I by 2 times. So 2 into 2 will be 4. Is 4 less than equals to 32? Yes, it is. So again multiply by 2. So it will be 8. Is 8 less than equals to 32? Yes, it is. Then multiply by 2 again. So 16. Is 16 less than equals to 32? Yes, it is. Again, multiply it by 2. So 32 is less than equals to 32. Yes, it is. So multiply by 2 again. So 64 is less than 32. No, it's not. So it is basically running for 6 times, which is closely approximate to log 32 base 2. So the time complexity for this problem will be order of log n base 2, because in this problem we are not actually adding by 2, we are actually here multiplying by 2. So due to this, it will be run, or we can say the value of I from 1 to n will be much faster as compared to plus 2. In the previous problem, initially the I was 1 and we have to reach to n by adding 2. So 2, 1, then 3, then 5, then 7, then 9, then 11, and so on. It has to reach to n. But here we are not adding, we are multiplying it. So 1, then 2, then 4, then 8, then 16, then 32, and so on. So it will be reached much faster. Due to this, it will be reached in log n time. Therefore, complexity will be log n. Here also there is a similar case. Let's take n as 32 also. Therefore I will be 32. Now, is 32 is greater than 1 this condition? Yes, it is. So we will divide I by 2, that will be 16. 16 greater than 1? Yes, it is. Again we will divide 16 by 2, that will be 8. 8 greater than 1? Yes. So divide by 2, 4. 4 greater than 1? Yes. Divide by 2, that will be 2. 2 greater than 1? Yes, it is. Divided by 2 again. So it will be 1. 1 greater than 1? False. So basically it is running for 5 times. So we can say log base 32 is actually 5. So the time complexity of this problem will be order of log n base 2. Now let's discuss some more problems in the next lecture.